Hello everyone, how are you today? Thank you for joining us and welcome to the second in a series of 3 webinars Julie is offering this quarter on the topic of managing data growth. So today she's going to be focusing on addressing database performance in big data environments. And I'm Diana and I'm your host today, and I'm just going to go through a few quick housekeeping items. Julie's presentation should only take about 20 minutes, and afterwards she's going to be taking questions from you in the audience. We'll be actually collecting questions along the way, so if you have some, please feel free to enter them into the control panel as you think of them. In addition, we're recording today's webinar and we'll be posting it along with all of Julie's other papers on the ESG website at esgglobal.com/data management. And with that said, Julie can take it away.
Great, thank you, Diana. So as Diana mentioned, we will be recording today's webinar, and it will be made available at our data management landing page at the website presented here. So just real quick from an agenda, one of the things that I find most organizations reacting to the term big data is they want to know, well, do we have big data? Well, we always thought we had big data, and now we have this new term called big data, and they want to understand whether or not their criteria happens to fit that definition. So the first thing is, we're going to talk about how we define big data. Then we're going to talk about when big data hits your operational environment versus when it hits the analytics and your data integration processes. But to start kind of at a high level, one of the things that we do at ESG is we conduct a IT spending intention survey every year to get a pulse of what organizations are looking for their 2012 priorities and where their priorities are in terms of IT spending. So one of the key things that we notice is that one of the top things is that organizations are continually looking to eliminate waste by improving key business processes. What that means is one of the top business initiatives that was going to have an impact on IT spending was the whole idea of improving business process efficiency. And that can be measured in a number of ways, but the fact that that was a higher responding item over controlling cost was new in this year. And we're going to talk a little bit about that. But the second point is that organizations still want to be able to control costs while staying competitive. A third key area is that the 24/7 global economy is looking at driving 24/7 business operations, and what that means is that IT needs to be able to respond to 24/7, which means it leaves little time for downtime or maintenance or making sure that things are performing optimally. So at the end of the day, this isn't a big surprise that the key message to IT decision makers from this survey was that we have to continually to look and position our technology, and for those that are investing in technology to continue to make decisions based on spending wisely. So when you look at what big data means and all of the market hype, one of the things that I mentioned at the beginning of this presentation is people are still trying to figure out, well, what does big data really mean? And it has some history tied to the .NET companies, about this whole hype around Hadoop and everything. But what's happened is that big data is taking on a life of its own, and the way that we look at big data and its definition at the Enterprise Strategy Group is really a data set that exceeds the boundaries, the sizes of normal processing capabilities, forcing you as an IT organization to take non-traditional or unconventional approaches to being able to meet the business needs. And what I mean by normal business processing capabilities, these are the systems that are running in your back office. These are the systems that are running in your data center to support the front office. These are things that you run on a day-to-day basis to run operations, to keep the lights on, and to keep the business happy. At some point in time, there's going to be a set of data that really challenges those systems' capabilities, whether it's in terms of throughput processing or whether it's in terms of response times or latency. There's a lot of different dimensions that we're going to talk about, but just to be generic and really look at things from a relative perspective, as soon as this data set that is of focus of the conversation requires you to look at things outside the box, that's when we start to categorize things as a big data challenge. And when we ask the IT organizations and previous research, all right, well, data management is all about managing data, but what are the top challenges that organizations have with supporting and managing its current database environment and supporting infrastructure? And when the top two responses are managing data growth and database size and keeping up with database performance requirements. Now, as Diana mentioned, this is the second of three sessions, webinars that we're hosting. The first one was really on managing data growth and the data volume itself. This one we're going to spend a little bit more time talking about performance. But the point of the matter is that when you look at big data and that previous definition, data growth and keeping up with database performance are some of those symptoms that make you start to feel like, well, maybe I have big data. There's a couple other dimensions in this research, but for now we're just going to focus on this for this particular session. When we asked the same survey respondents when they answered database data growth was a particular challenge, we asked in particular what specific challenges were they facing with respect to the database size and or growth. And again, it's probably not surprising to see that the number one answer is increase in storage capacity requirements, performance degradation. It makes a whole lot of sense, and increasing cost of infrastructure, right? If you think about it, if you have more data in your database and you want it to keep it performing, you either have to add CPU, add resources to your database environment to keep the environment running business as usual, or you might improve the storage infrastructure. You might add higher performing disk I/O capability to keep up with maybe some storage I/O bottlenecks. But the point is that as data volumes grow, it does have a corollary impact on performance if you don't have a correlated investment in the underlying infrastructure. So the folks that answered the question that they found that their second biggest challenge or the biggest challenge was database performance, we asked them what were the major causes of database performance issues. And what we saw here was an increase in transactional workload was the number one answer. And you can see storage bottleneck, too much data, poorly written application code, add more users, new application functionality. But the fact that the number one answer is increase in transactional workload, what that tells us is that organizations are trying to do more with less. If we look at historically in the economy, people were not spending money on IT infrastructure as much as they had in previous years because they were tightening their belts, they were buckling down and trying to deal with just the global economic situation. But an increase in transactional workload means that these systems were designed to handle a certain workload, and now all of a sudden we're adding more transactions, and it's starting to create bottlenecks. And all of the rest are, symptomatic of trying to do more with the current environment without doing updates. So when we look at those two challenges and some of the details behind it, let's talk about, when that data becomes big data. If you look at a traditional data center infrastructure, you're going to have information that comes in from your source systems into, let's use the example of an e-commerce transaction processing environment. My transactions, I purchase something online, gets entered into a database. That database gets replicated multiple times for test and development. The production system, the test and development copies all get copied and backed up for data protection and disaster recovery. And there's also going to be a set of data that gets copied into analytics and for reporting to management to make sure that they're selling the right products at the right price and making money. If you look at this process, any time that you add more transactions to that transaction processing system, there's going to be a corresponding impact downstream in terms of not just performance in processing that data, but also the performance in copying and making those test and development copies, copying and making backup environments, replicating data. The more data that comes into the system, the more it requires increased investment in infrastructure downstream. And then not to mention analytics. Traditional analytics typically did not take that detailed transactional data. A lot of times that the transactional data was aggregated and summarized in these analytical reports. But what's happening is if you go back to the initial premise of this presentation, organizations need to improve business process efficiencies. Well, if you look at this setup and you add more data, one of the ways that you can look at improving your business processes is by looking at this process of consuming information, analyzing it, creating test and development copies. You need the detailed data to produce those higher quality analytics to find out where the problems are, where the bottlenecks are. So when we look at big data and operational systems, let's go back to what we said at the beginning. If you have a lot of information coming in, a lot of people are transacting on this e-commerce data, performance is measured a number of different ways. And uncontrolled data growth has an impact in performance, in time, efficient use of hardware, software resources, people resources, and also risk. If you have a large volume of data and your database crashes, how long does it take to recover that database? The larger the database is, the longer it's going to take to recover. So when we look at big data volumes in your transaction processing systems, too much data can definitely have an impact on how long does it take to complete that transaction. How long does the database take to commit that record into the database, replicate it for a DR process. The bigger the production database, the bigger the test and development environment. So if you measure performance and how long it takes to roll out a new product or a new feature, the test and development process has the duration of that process is impacted by the size of the database. How long does it take to create a new database for test and development? So too much data in your test and development environment can also impact performance in terms of your test cycles. And then if, again, I mentioned at the beginning, or a little bit earlier, if you have too much data in your production database, for every production database, most organizations will have a full backup copy. They'll have daily incremental backups and a full backup. They may also back up their test and development copies. So you've got this, cumulative effect. But the fact is, what happens when you want to recover it? Again, it was probably a lot quicker to recover a smaller database when it was 2 years old versus when it was 10 years old, carrying around 8 years of old transactional data. So performance is measured in different ways. And there are a variety of different solutions out in the market specifically to address these types of performance challenges in a transaction processing system. The point here is that what you want to do is find out when big data or data volumes start to impact performance as you measure it, and keep your transaction processing system within those normal processing bounds. You don't want your transaction processing system to be become that system that has to be managed unconventionally or non-conventionally. So the types of solutions that we're seeing in the market to address what I call operational performance really falls into two categories. One is where you can better manage the data itself. So this is that data volume or data growth management strategy. And we talked a lot more about this in the previous webinar. But there's also this category of resource management. So this has to do with how can you improve performance by just better managing the resources to support your production system. I'm going to talk a little bit more about each of these, but I want to focus a little bit more on, for example, the resource management, performance optimization. Now, one of the things that happens when you increase the volume of data is that you might get spikes or bursts of resource load on whether it's CPU or I/O throughput. And a lot of organizations will look at that as an alarm will go off and say, hey, I think we need to upgrade our database server, we need to add more CPU utilization. But really, when you look at it and you look at the trends, really what might be a better way to address those kind of performance boosts is to either dynamically add more CPU capability or dynamically add more I/O. There's a few companies that are in the market now that are addressing this particular one, and there's More VRP is a new startup that I really like what they're doing. On the database virtualization side, what I like here is instead of creating a full copy of your test and development environment. You can do a virtual snap of your environment. So there's companies like Delphix out there that are really doing a good job of kind of creating these thin provision test and development environments, so that from a resource utilization perspective, you're optimizing what you have. You're able to get more out of what you have, and really look at better managing what you have and doing things like quality of service. We're going to spend a few more slides now talking about information lifecycle management. I know that this is a term that has been tied to tiered storage, but I go back to it because information lifecycle management is really kind of taken on to mean more than just tiered storage. It really has come to mean more about applying data classification to your data and applying a process to address it based on the value that data has to the business. For some of you who may have downloaded one of our market landscape reports called Managing Data Growth, we focused on database archiving, and the architecture slide that you see here is, for example, is a pretty good representation of the types of solutions out there. IBM, Optum, Informatica, database archiving, Solix has a solution. There's a few more out there. And what I want you to focus on here is data that is being added to the database environment in a transactional processing system will have rows that are sitting in tables, and over a period of time there will be rows that are going to be hit on a regular basis. There's going to be rows that are going to fall off in terms of the access patterns, and then there's going to be data that you just really don't need anymore and you can delete. Database archiving, what these solutions do is they'll basically selectively identify data that doesn't fit that hot data category anymore based off of a business policy, and it'll move it to an archive database. So one of the challenges here is that you do need to know what the business rules are, and you need to be able to translate that into DBA speak or SQL. And you need to be able to stand up an archive repository. You need to be able to have some kind of data access layer. Some cases it's a database link. I'm using some techie terms here, but for those that aren't technical listening on the webinar. But the idea here is that the end user will have access to that data. So what happens from a performance perspective is, you can imagine when you start to offload some of that aged data, you're going to lighten the load. I like to akin it to taking the bricks out of the trunk. If you have bricks in your trunk, you're not going to get great gas mileage. But if you take it out, and you're going to find that you're going to be able to get a lot more miles per gallon than you were when you had all that dead weight in there. I'm going to talk a little bit about database partitioning, and the reason why I kind of go back to these two solutions from a performance perspective is I get a lot of questions from end users on what's the difference between database archiving and database partitioning. So here, again, it's the same idea where you have a relational data model, but rather than looking at things from a row perspective, you institute business logic into the physical layout of the data in the table itself. So that instead of surgically removing rows from one place, inserting it into another place, and then deleting it from that source, that you're using a database partitioning mechanism which incorporates that business model into the physical layout at the time that the data gets stored. So instead of doing row deletes, what you end up doing is dropping a partition or using something that's a little bit more clean from a physical layer perspective to classify and tier the data. Now what's nice about database partitioning is that just by having the right partitioning logic that's aligned with the business rules, we have seen, for example, companies like Tier Data show incredible performance improvements without actually archiving the data. This becomes a more elegant solution when really what you're trying to address is, if I have a ton of data in my database, I'm not ready to create an archive repository, but I do need that performance boost. I've spoken to a lot of end customers that have leveraged this solution like Tier Data's, and they absolutely love the fact that they're getting this performance boost to the point where they didn't need to upgrade their server, add more CPU utilization, and really get more mileage from what they had. Now, I have a build here that has comma-tiered storage. So database partitioning happens at the database layer. There's another way to look at getting a performance boost when you have a lot of data, and that is not just tiering the data, but looking at the underlying infrastructure and that storage layer, where again, you've heard of things like solid state drives and you know, fiber channel disks, and then you have your SATA drives and the lower, maybe the higher capacity, lower performance disk drives. If you could align those business level partitions with those types of technology, you'll get an extra added bonus performance boost. Again, it all depends on the type of performance challenges you're having. If it's a storage I/O or a throughput perspective, tiered storage might actually help, especially from a overall cost perspective. Again, you know, solid state drives are getting a lot of attention in the media right now. You know, ESG has I have one of my peers, Mark Peters, publishes reports on this market, and I highly recommend that if you're interested in learning more about where the solid state drive market is impacting the OLTP application market, and he's got some great reports on our site. But the idea here is that comes at a cost, and you don't want to create an entire database running on solid state drive if you don't have the budget for it. Maybe you buy just enough to cover your tier 0 data sets, the data that you're just creating. You combine that with things like database partitioning, and again, it's a way for you to keep data within that traditional data center processing model and not have to look at things like big data. Which brings me to our next section. Big data and analytics and integration, and this is really where if you look at where people are placing the term big data, it has a strong connection to data analytics. So when we look at analytics, it's a little bit different, right? We're not talking about transaction processing. We're not talking about we're talking about a completely different type of workload on your infrastructure. And performance from an analytics perspective is not measured the same way, at least from a business perspective. Performance here is usually measured in key performance indicators. And when you don't have the data to help you do proper analytics, you run into challenges. So what's happening is businesses want to do run their business more efficiently. They want more data to be able to conduct the analytics to find out where there are issues. So if you don't have enough data when you're running analytics, it could introduce margins of error. A lot of ways that people were getting around this was they're sampling their data set so that they conduct analytics in their traditional data center technology platforms. But when you don't have enough data and you're sampling, you could miss something, and that introduces margins of error. Another example is if you don't have the right data. Let's say you have data sets that are coming in, they're getting aggregated and provided as part of your business analytics reporting environment, but you don't have any of your e-commerce data, or you don't have any of your social media, customer feedback information in there. So what does that mean? That means that not having the right data prevents what? It prevents you from being able to add revenue generating opportunities. The other thing is, what about not having recent data? A lot of times what happens is people update their analytics environments in batches. So if they're updating their data in batches, whether it's weekly or monthly, and marketing operations want to have the ability to market real time, they're missing that opportunity. They're missing that point of when the customer is about to abandon the shopping cart. So not having recent data misses opportunities. So what's happening is that we're seeing these are the kinds of reasons why the businesses are asking for more data. And when they ask for more data, it's either, in 3 dimensions. And we've heard these dimensions, used in context with big data. Volume, velocity, and variety. You got the 3 V's there. And we see that as well, but it's got to be tied to something. If I go back to some of the research that we conducted, we asked organizations, all right, how much data are you analyzing per exercise? And if you look at this chart, there's a lot of organizations to the right of 500 gigabytes or more. That's a lot. In fact, just trying to conduct analytics on 250 gigabytes is pretty challenging using a standard desktop analytics application. You really need to start looking at a platform outside your traditional analytics environment if you're really looking at, look at that. You've got, 3% of them are between 26 terabytes and 50 terabytes at a time. So this is so here we're saying that more than half of the organizations that we pulled are processing at least a half a terabyte at a time. Now this is the variety. Now we started to see organizations having issues with their analytics as soon as they started to add more sources. So it's okay with 1 source, 2 source, 3 sources, but as soon as they got to 4 unique data sources, we started to see organizations, having a little bit more issue keeping up with the load using traditional data analytics platforms. And then from a real-time or near real-time perspective, we asked how frequently is data getting accessed and when are people having challenges? And what we found is that people were fine with batch monthly, batch weekly in terms of challenges, but as soon as the timeline was getting shorter and they wanted to have information more real-time, if you start to combine those things, you can imagine it's like drinking from a fire hose. I know you've heard that cliche over and over again, but really when it comes to data, it is. It's like looking at a traffic jam, at rush hour. So a couple of areas that, we've seen advancements in technology around this big data zone. And a couple of technologies that I want to call out here are things like MapReduce programming frameworks. So these are like Hadoop. Actually, if you really look at the historical significance and the term, where big data really first came out, it was in some of the early origins of Hadoop. MapReduce isn't new, but applying MapReduce as a programming framework to a large data set using a distributed computing platform so that you can run a data processing or an analytics task on the entire data set at once is what is new. And being able to do that in a infinitely scalable, or I shouldn't say infinitely, but pretty close to infinite scalable environment. So MapReduce is something that we're seeing a lot of hype around. There's a lot of conferences that are popping up. We had Hadoop World last fall. We've got the Strata making data work for you conference coming up in just a week. So there's a lot of I think GigaOM even has a big data conference. So there's big data and MapReduce frameworks in Hadoop are really taking center stage. And a couple different other areas, massively parallel processing, shared nothing platforms, analytical databases that are designed to run on MPP platforms with columnar data storage seem to be filling the niche of these complex analytics needs on large volumes of data. And then another area that we're seeing a lot of development from a market perspective is on these parallel and distributed file systems. And the idea here is that if you have a lot of data and it's in a giant file, or if you have a lot of little files that are concatenated into a giant file, how do you ingest, how do you process and load that file with higher performance? So parallel and distributed file systems are really starting to show up in the analytics community. In fact, if you look at the first one and the last one, Hadoop is really a combination, well, actually it's a combination of all of these, really. It has a HDFS as the Hadoop distributed file system. Hadoop is also this MapReduce programming framework. It runs on a shared nothing compute cluster. So again, all of these technologies are really starting to make a play in big data. So when I look at that in terms of that first picture that we showed where we were comparing traditional, conventional data center technology versus big data, where we see kind of a line drawing in the sand is, the traditional data analytics architectures were either these servers running on someone's desktop with direct attached storage. They'd get an extract from a data warehouse, plug it into their analytics environment, and off they go. We've started to see the need for more enterprise class storage, or some of these advanced data management features get introduced into those analytics environments. So then you see kind of the evolution of it using network storage. Then you see the evolution of using a high availability server configuration for those data analytics environments. And then you go over to the right where you have these big data analytics architectures, things like high performance computing, and then, as we mentioned in the previous slide, really these MPP, distributed computing, compute clusters with direct attached storage. So these are really where we're seeing the architectures evolve. But they usually happened as part of a project. People don't. I'm going to go back. People don't just wake up one day and say, "Hey, I think we need to deploy a Hadoop cluster." There's usually some project or some need or some data set that's obvious, and it takes them out of their comfort zone of their traditional data center architecture. So when we asked the question for those organizations that said they were planning to deploy a new analytics solution in 2012, we asked what were they planning to deploy. And you can see what's interesting, and maybe it's not so shocking for most of the folks on the phone, is that most said 45% said a custom developed solution. So what that says is that with all of this emerging technology coming out there really isn't one that is taking the lead. And people are still looking at analytics as their IP. They're looking at it as something that we need to build internally. And the downside is that there's a lot of opportunity to improve those operational efficiencies. I mean, it's just building a custom developed solution is tricky to maintain. You have to have the staff, the skills, the programming, the infrastructure to do it. What I also like is if you look at the second one, data analytics cloud computing service, or software or infrastructure as a service to support analytics, was number 2. So I think we're going to see a lot of movement in that area this year. So I want to talk about Hadoop. We did ask, what are your organization's plans to implement a MapReduce framework? And specifically, we called out Apache Hadoop. Now you'll notice that only 8% of this sample set, or this panel, was using it. 13% were planning to implement a solution this year. Now, if you look at the citing, this data was taken in August of 2011. That's when we published this report. And I call that out because we are in the process of conducting some more research to look at this trend. And what we're going to be publishing in probably about 4.5 months is a report where we ask the same question, and we're going to look at trends. So it'll be about a 6-month trend. And what we're hoping to see is that 35% that says no plans to implement at this time but are interested, we expect to see a lot of those turn into plan to implement within 12 months. So this is typical of an emerging technology adoption curve, and within, like I said, in about 6 months from that August timeframe, we'll start to show some trending data specifically around Hadoop and MapReduce. And again, we did ask for those that were planning or that had implemented MapReduce, what was the biggest reason, and the number one reason was larger data sets. So you're only going to go to Hadoop when the data set is large enough that requires you to look beyond what you're currently doing. I mean, there's a lot of other reasons. I like the third one, experimental, to see if the platform is applicable. To replace custom scripts, I wasn't surprised to see that. Different ways to do ETL or analyze new sources of data. But still, when it comes down to it, you're not going to invest in Hadoop unless you have a really large data set that just is going to be so, to deploy it using something like Oracle or DB2 just is not economical. And you have to do something non-traditional. So kind of coming back around to performance, right? What was that whole point about big data and talking about Hadoop? Because the reason why you would move to this is because you have a performance requirement that is not being met by your traditional architecture environment. And it comes at a cost, right? Do I really need performance? And performance, again, isn't always just measured by time. It could be, quality. It could be I am missing an opportunity to sell more to my customers. And in order to do that, I need data, lots and lots of data. So here's where we're kind of seeing big data architecture sitting complementary aside your traditional data analytics architecture. And we also see that organizations are using Hadoop as a landing spot for some of their more complex analytics. So it's not uncommon to see a Hadoop cluster running data processing to support maybe a couple of data marts or some analytics environments. or you're feeding an analytical database to do more complex analytics. And we're going to be doing some labs over the next couple of months. ESG Labs does technology validation, and we're going to be publishing some results on different ways to compare and contrast workloads, whether you're using Hadoop or you're using an analytical database. Now, I mentioned integration. So I have this little build here to show you that, there are arrows that go in between each one of these systems. So when you look at technologies that are emerging to really help address these data integration needs, big data means bigger pipes. Well, not necessarily, right? You don't always want to invest in 10 gig in your data center, but maybe what you might do is something like WAN optimization. So there's a lot of technologies out there that can help make your usage of the current network more efficient. We do see organizations migrating to 10 gig on the Hadoop cluster backplane. We see organizations using things like InfiniBand for the analytical database backplane. But really, between these environments, we are still seeing just 1 gig be the common pipe for it. But it doesn't mean to say that you might want to pay attention to the traffic and when data gets loaded, when data gets extracted to optimize those environments. Another thing that happens in these arrows are things like extract, transformation, and load. There's a few technologies out there that do what's called data integration or data integration accelerators. SyncSort is a perfect example of one of those, where what they'll do is they'll take the sort algorithm and they'll run it in their high performance environment, and it offloads the need to increase the number of CPU or the number of staging tables that you might need in your data warehouse. So those are some technologies to keep a lookout for when we're talking about data integration. Another really interesting thing is on the Hadoop side, building Hadoop clusters is, if you have a team that's skilled at building compute clusters, that's great. But building a Hadoop MapReduce program requires a developer skilled in Hadoop. And if you look at, as this technology becomes more popular or more standardized in the data center, it's really expensive to have a team of Hadoop developers on staff all the time. Companies like Informatica are taking a thought leadership position. They're making that process much more graphical user interface, easy to do, easy to use platform. They have this thing called HParser, which allows you to use their IDE and build these transformations using point and click, and then it actually generates MapReduce code on the back end, and it can run on a Hadoop cluster. So again, there are innovations happening that it's going to make it a lot easier to leverage technologies like Hadoop. So as we look at where we are in the presentation and our time, I want to wrap up by saying a couple of things here. The point is that performance doesn't come for free, right? There's always a trade-off, and there's always a different way to look at how you can improve performance in your environment. And you really need to know what are organizations willing to pay for and where are they willing to sacrifice. You can always invest in more hardware. You can always invest in more infrastructure. You can invest in faster storage. You can put more CPUs in your, you can get higher density servers with higher performing CPUs, but they all come at a cost, right? So if you want to look at how do you make your business more efficient, how do you improve the business, that's the question when you start to ask, what does performance really mean? And you can put a dollar sign to it that's more than just your infrastructure cost. So whether you're a vendor listening to this or you're an end user looking to improve your performance, I look at performance as a math equation. And at the end of the day, you have to have an ROI. So your ROI is equal to the value that you get over the cost of the investment that you make. So I'm going to turn it back to Diana because I know that she's got a few questions keyed up, and I want to make sure that we have time.
Yeah, we have a couple of questions here, and I just wanted to remind everyone to not be shy and enter in questions in the control panel. as we go here. We have a few more minutes available. So the first one here, Julie, is actually a kind of a two-part question. It's when you're doing database archiving, isn't there a performance hit while you are archiving, or when you're accessing archived data?
Oh, that's a good one. So I had mentioned from the operational perspective that when you archive data out of your database, it's like taking bricks out of the trunk. But there is the effort of taking the bricks out of the trunk, and yeah, there is some known performance implications, especially when you are using a technology that's based off of row deletes. So yes, I mean there might be a performance overhead associated with selecting the data, inserting it into an archive database, but the performance really is when you delete it and you have to do some cleanup, like reorg the tables. But usually that comes, in a batch. It's a batch. It's a one-time hit. But the benefit is that usually those databases and those tables will be much more performant. The access will be much more performant. So it's a trade-off. I actually, the second part I think you said was, what about when you're accessing the archive data? So I've actually seen in some projects, what I've been working with end users is that the access to the archive data is faster because there are fewer people accessing the archive data, so you don't have as much user contention. And the other thing is that a lot of the way that these systems work is they usually have a certain number of users only access archive data, and then most of them are just accessing the production data. So overall, I mean, it can be more performant. Sometimes if you store the archive data on lower cost media or slower infrastructure with less CPU and slower spinning disks, there might be a hit, but that's the whole point. If it's not as important and you can, you can wait a couple of times for your hourglass to spin, that's okay. So,
okay.
What else do we have?
Second question here is, you mentioned that Hadoop is not necessarily high performance. My experience has been that you can get sub-second response times in certain applications. Can you comment on that?
So Hadoop has been developed and designed to be able to process large batches of data or analyze large batches of data at a time. And if you look at Hadoop and starting up a MapReduce task, it's mostly JVM, Java. So just to start a MapReduce task has an overhead of about 15 seconds. Now you can get some efficiencies built into that, by reusing JVMs and everything. But the point is that people should not expect to get like these microsecond response times with Hadoop. Now, the exception is, and I'm sure this person will have to get their name because it's a smart question, but there's some exceptions, and that is there are things like HBase and some of these applications that sit on top of it that do allow you to kind of query a subset of data. And we are starting to see applications built on top of that address some of the performance issues. But if you are running a true MapReduce task, there is at least a 15-second latency, at least for the first time, just to start up the JVM. I'd love to hear more for those that are using Hadoop and have seen these higher performing Hadoop clusters. I'd love to hear it. I will say we have a market landscape report coming out soon on Hadoop distributions. So we are starting to look at comparing and contrasting, some of the commercial distributions like Cloudera, MapR, EMC, Greenplum HD just came out. IBM has their own distribution. Oracle is reselling Cloudera. There's a couple more out there that are popping up, and I'll use an example. MapR actually, they do some really cool stuff where they actually write the code that runs on the MapReduce cluster in C++. So they get rid of that 15-second latency. So because it's written in the machine language that's more performant. So those are the exceptions and stuff. But stay tuned for that market landscape report.
Good. Okay, and I just have one more. Can you comment on how someone who would compare the investment required in real-time versus near real-time analytics?
Okay, so when we showed that slide that showed the real-time versus near real-time analytics, this is an interesting one because, the requirement for real-time analytics gets a little fuzzy because people are like, well, what do you mean by real-time? And is it really micro-batch real-time? And, when we talk about real-time, it's streaming analytics. Data's coming in, you're analyzing it over a window, and that system requires, big pipes to be able to drink from the fire hose analyze the water as it's coming through and pick up the giblets, and it's limited based on things like, you know, how much memory is in that box that's doing the streaming. We see a need for things like that where you need to make a sub-second decision and it impacts someone's life, or it impacts, you know, a huge amount of money. Like the need for real time has a direct impact on money or life. And, you know, those kind of things, there's a few, you know, known use cases. But the rest, if you could wait 15 seconds for a response, the difference in what you would invest in is incredible. So I always, when I talk to, you know, the clients that I do a lot of consulting work for, I ask them, do you really need streaming real-time analytics? Because you're going to have to build something custom for you, or you're going to have to invest in infrastructure. Versus, you know, what if you did this thing like micro batching, or is 15 seconds or is 30 seconds okay? And it might be a difference of $300,000 versus, you know, $3 million. So those are the differences.
Yeah, that's a big difference.
It is, yeah. Looks like we're, we kind of went a little long. I know that we had only planned to be 20 to 30 minutes, and these were good questions. But let's see. Like I mentioned before, this is, you know, this recording is this webinar will be recorded, but Diana, maybe you could provide more of the details.
Yeah, so it'll be loaded up on the data management page on the ESG website tomorrow. And just as a quick reminder, Julie's third webinar on this series will be on March 29th, and watch your inboxes for more information on that in the coming weeks. Right. The topic for that one is going to be efficiently creating database copies for test and development.
Oh, so we're going to talk about the test data
Right.
process efficiencies. Great. Right. So for those of you that asked a question online, I think one of them was, where can I get these slides? You can get them on the website listed here, and then, you know, we'll stay on for a few minutes more online answering the questions. But for now, I want to appreciate everyone's attendance and thank you for the time, and we hope to see you on the third webinar of this series. So have a great afternoon, everyone.